here who invited me. I'm most grateful for this academic honor, which I appreciate very much. The Dr. Honoris Causa I consider as one of the most best known and highest academic distinctions which exist. So I appreciate it warmly, and I also appreciate warmly the hospitality. Indeed, I am, since my early young days, a great friend of Greece, and since I was initiated really at school already by 6 years of ancient Greek, it's a great pleasure always for me to come to this country and to be here again. I've been asked to say a few words about my academic career, and I don't think I need any slides to do this. Something has been said already. But I just try to elucidate to some degree at least a few aspects which motivated me during a long period of time. I'm now almost reluctant to say so, but it's 52 years that I'm working in science at this moment. What motivated me really to stick to a specific topic which I'm following up until today. I can roughly differentiate my career into 4 different phases. An early one where I studied the influence of viruses on chromosomal modifications, trying to elucidate whether this may play a role in cancer. It was a period which was really only the beginning of activities. Subsequently, I worked for quite a while on Epstein-Barr virus and Burkitt's lymphomas and nasopharyngeal carcinomas, stimulated particularly during the period in Philadelphia in the United States with the Werner and Brigitte Händel at this place. And at that time we were able to identify the DNA of the virus in every tumor, every Epstein-Barr virus positive tumor from Burkitt's lymphomas and nasopharyngeal carcinomas. Each individual cell contains the viral genome. For me, this was, in a way, kind of an academic highlight, because it was for the first time that we could demonstrate that the tumor virus persists in every one of the specific types of human tumor cells. So subsequently, I worked for about 30 years, mainly on papillomaviruses, and I will come back to this in a moment. And during the past 5 up to 10 years, particularly my wife and I, we are extremely interested in the analysis of single-stranded DNA viruses which are widely spread. Everyone sitting in the room carries them in his or her peripheral blood. And the role of them had been quite unidentified for a long period of time, but the system starts to be a little bit more clear in these days, and it's for me a very exciting period again. But let me come back to the papillomavirus work, because it is most frequently discussed. Indeed, throughout my life I was more interested in specific diseases, being medically trained, in specific diseases than in specific agents causing cancer. But of course, the interest was mainly addressed towards the question, if a disease, if there exists some evidence, epidemiological evidence for linkage of a disease to infections, can we identify those infections? And if we identify them, can we do something against those types of infections? And indeed, in the early 1960s, in fact, in the late 1960s, there was a first report on a possible viral involvement in cancer of the cervix, namely of herpes simplex type 2, the so-called genital herpes virus. And the suspicion was that due to the elevated antibody titers against this virus, this might be a potential candidate causing this type of cancer. Well, since during my Philadelphia period I worked quite a lot on hybridization, nucleic hybridization methods to demonstrate Epstein-Barr virus DNA in tumors, we felt that we were well prepared in Würzburg in Germany to test this question, as we thought initially, relatively quickly, by trying to find in those types of tumors the herpes simplex type 2 DNA, and we failed entirely to do so. There was none visible in any of the tests which we did. So I became very skeptical about this type of result and looked for other potential candidates for this type of cancer, cervical cancer, since the epidemiology was really hinting at the fact that this cancer is linked to sexual contacts. And I came across a couple of reports in the literature that genital warts, a nasty and very unpleasant problem, that they may convert occasionally into malignant tumors. Malignant tumors, it's a rare event, but it happens from time to time. I've found approximately close to 100 reports in the literature dating back for almost 100 years from that date when we started in the 1970s to work on this problem. Now, I speculated that if this is this agent, which I could see in the electron microscope being a typical papillomavirus particle, if this agent is causing those types of tumors there, why wouldn't it be possible that it causes much more efficiently cancers at a different site, namely at the cervix? So this was a reason to start to analyze the genital warts for specific virus, which had not been identified up to that time, besides the fact that one could demonstrate it electron microscopically. And in those cases, it became quite clear early that the virus in genital warts must be quite different from common wart viruses. And it took us quite a while, until the end of the 1970s, before we were able to purify, clone, and analyze the DNA of this virus. The disappointment was big because we didn't find it in cervical cancer. But by finding a related agent, which is now called HPV11, initially in laryngeal papilloma and subsequently also in genital warts. With that probe, we had better material and could find some, what we called in so-called southern blots, a very specific method to demonstrate DNA, some evidence for related sequences. And two of my former students were asked to analyze and clone those sequences. Have been quite successful. It turned out to be 16 and 18 DNA, the first isolations of these types of viruses. And we instantly saw that they're present in at least 70% of all cervical cancers. There were a number of additional studies which came up subsequently, in part in our laboratory, in part also in other laboratories, because we distributed those probes globally, and which clearly showed this virus must be, or these viruses must be responsible agents. A couple of additional isolates were later obtained, but as a result of these types of studies, as you know it, after some initial difficulties which we had with some companies, particularly in Central Europe, vaccines have been produced initially by American companies, and these vaccines turned out to be highly efficient. They are safe and have been now applied to more than 100 million of girls in the meantime. The side effect rate is exceedingly low. It's about one side effect, an allergy against the protein, about 100,000 vaccine doses which are provided, which is lower than many of the vaccines which we are presently providing to small children. And it's clear now that this vaccine is preventing the precursor lesions of cervical cancer. It's not clear yet whether it really prevents cancer, although it's most likely that it will, because the latency period between infection and the appearance of cancer is in average 15 to 25 to 30 years. And so, since the vaccine has been licensed in most countries in 2006 or 2007, the time period is too short to demonstrate this. But in a way, everyone working in this field is clearly anticipating that it will be effective against cervical cancer. And the sole message which I will add at the end of my brief talk is that the vaccination, which was initially recommended for girls, usually in age groups between 9 and 14 years prior to reaching sexual activity and maturity, said this because the vaccine is only effective as a preventive vaccine, not as a therapeutic vaccine, that this vaccine should be also applied to boys of the same age group. And I was frequently, a little bit provocatively stating, if we could only vaccinate boys, we would probably prevent more cervical cancers than by only vaccinating girls, because in most societies globally, the males between 15 and 30 years have more sexual partners in the respective age groups of females. And so for those reasons, of course, they're spreading the virus. Anyway, it's a long story. With many additional details, which I cannot tell you here for time reasons. Fortunately, this came, as far as prevention is concerned, to a happy end. As far as therapy is concerned, of those people who are already infected, the situation is much more complex. Of course, obviously, interventions, the secondary prevention, as developed by Georgios Papanikolaou, turned out to be extremely important to prevent this type of cancer. But of course, it requires, in many of these instances, surgical intervention to remove those precursor lesions. And the therapy of cervical cancer also improved. But nevertheless, there's still quite a number of problems open which deserve intensive research. They also involve intensive basic research to study the interaction, hopefully in the future, between these specific viral proteins mediating this type of cancer and the some hopefully developed chemical compounds, because even if you look only at the precursor lesions, it's a major problem throughout the world, everywhere. Cancer itself, due to that is the merit of Papanikolaou, in many countries where the screening procedures are done well, declined quite substantially by 70 to 80%. But still, much more work needs to be done in order to do something here. So once again, thank you for the very kind invitation to come here, and thank you for the opportunity to be here at this stage and also to receive this honor, which I warmly and greatly appreciate. Thank you.